Hello and welcome. Today we are going to solve activity 2.3.8 residential water supply question or procedure number 2. Okay, if you guys read the questions, we have 8-inch ductile or cast iron pipe with flange fittings, and we are going to start to answer the question number A. Find the total dynamic head and the actual water pressure at the water meter of this facility. Okay, so to be able to solve these questions, first we are going to start to calculate the static head, and then we are going to calculate the head loss, and we are going to calculate the dynamic head, and then we are going to convert this dynamic head to actual pressure to be able to solve the number A. So there are a lot of math part involved now. So let's start. First, we need to calculate the static head, and the static head, the formula says elevation of the water tower is given to us 350 feet. The elevation of the water tower is 527, and elevation of the meter is 350 feet. So static head, if I calculate here, static head is 527 minus 350. The answer is 177 feet. This is static head. Now, to be able to calculate the head loss, so because I need to calculate the dynamic head and I need the head loss. So I need to use the formula for the head loss formula. And what was the head loss formula is HF equals for the head loss 10.44 times L times Q to the power of 1.85 divided by C to power of 1.85 times the diameter of the pipe 4.8655. So this is the formula that we are going to use. So first I need to calculate the L here. So I need to find the L to be able to substitute the L, the total length, and I'm going to plug them in all the numbers to calculate the head loss. So let's calculate the L, length of the pipe. So if we check it, so we have 4.1 miles from the tower, from the water tower, right, to meter. So first I need to convert this 4.1 miles to feet. 4.1 miles times 500 to 80. If I multiply them, I can convert the feet. And if I convert the feet, so the answer here, guys, on the length of the pipe is 2100 648 feet. Now I need to convert the fittings also. I need to find the length of each fitting. So I'm gonna calculate the 2 90-degree elbows, 2 gate valves, 17 line flow, 6 branch flow teeth, and 1 swing check flow. So where can I find them actually? Where can I find them? I can use this Hazen-Williams and the equivalent length PDF document that is provided to you. You can find each one. So if I check it on the first one, it says 2 90-degree elbows. So which one I'm going to use from the PDF document? 8-inch ductile or cast iron pipe with flange fittings. So I'm going to go to flange fittings and I need to find 8-inch. So because it says the diameter is 8 inches. And then let's say I'm checking 90-degree elbows, 2 90-degree elbows. So if I go to elbows, these elbows, regular 90 degrees elbows for the 8-inch, as you can see, each is 12 feet. I have 2 of them, 12 times 2, 24, and so on. For the valves, you are going to check it, teeth, you are going to check it, return bands, you are going to get it, the information from here. Since it says the 8-inch diameter, so you are going to use the values from here, guys. Okay, from the 8-inch part, right? From the 8-inch. Now let's fill them up the information here. Okay, let's check it on the previous screenshot that we have. Okay, let's continue. We have two 90-degree, each one is 12 feet, so I'm gonna multiply with 12 feet, and if I check it, here is 24 feet, and then here for the 17 line flows, each one is 4.7 feet, and when I multiply them, um, 17 times 4.7, 79.9, and I forgot to gate valves. If I calculate the gate valves, each one 3.2 feet. When you multiply with 2, 6.4. There are a lot of numbers here, but you guys hearing me in the same time. And 6 branch flow teeth. Each one is 24. So if I multiply 6 times 24, the answer is going to be 144. And one swing check valve, 90 feet each. So this one is 90 feet. So when you add them all, guys, in a short, when we add them all, 21, 992.3 feet. So this is the length of the pipe, including fittings, guys, goes here, the L. So you are supposed to substitute with this L with this number, 21,992.3 feet. And then, so the Q is given on the question, the Q is given to us 110. Q is given to us 110. So I can substitute the Q with the 110. Okay. And then C, you can get it from the table. It says the iron, cast iron, or whatever. So it is 100. So you are supposed to substitute this C with the 100. And the D is given to us here. It says the 8-inch ductile or the cast iron pipe. So you're gonna substitute this D with the 8. So when you plug them in all the values on the formula, HF equals 11.05 feet, or let's say 11 feet. Okay, that's the head loss. Okay, now is it completed? No, because the question says us calculate the dynamic head. So what is the dynamic head formula? Static head minus dynamic head equals dynamic head static head minus, what is the static head? I calculated 177 minus head loss. What is the head loss? We just calculated head loss 100. The head loss we calculated 11 feet. So when you subtract 177 minus 11, 166 feet is your dynamic head, guys. Okay, this is your dynamic head calculation. So we need to convert this to pressure to be able to calculate the actual pressure. So actual pressure is actual P equals dynamic head times 1 over 1 psi over 2.31 feet. Basically, you are supposed to divide 166 divided by 2.31. So actual pressure from here, when you put them in formula, 72 psi. That's the answer. Okay. It looks messy, but this is how you are supposed to solve them. Of course, you are supposed to solve them with a nicer page or the blank page. It will help a lot better actually. So 72 psi, this falls within the acceptable range of the residential distribution, which is 40 psi and between 80 psi. Is it between 40 psi and 80 psi? Yes. Do we need the any pressure reducer or something else? No, we are good. So this is how you are supposed to solve the A. Now I'm going to move the B. Okay. Let's move on to B. What is the static head at sink on the second floor if the sink faucet elevation is 14 feet above the meter elevation? So we have already calculated static head on the first question, and we calculate them 177, right? So we have calculated the static head already 177, right? On the A, we have already calculated, but this time we are going the second floor, which is the sink is elevation 14 feet above. When you go to above on the when you go to second floor, third floor, what will happen? Of course, static head is going to be decreased. So you can calculate them static head this time, and the pressure also is going to be decreased because you are going the second floor, third floor. So you are going higher level. If you got higher level, the water pressure is supposed to, of course, falls down. So then when you plug them in the static head, you already calculated, right? 177 on the previous question on the A. If you subtract them 14 feet high, when you subtract it, the answer is going to be 163 feet. That's the answer for the B. Or you can just subtract them 527 minus 350 minus 14 will give you the same result. Now let's go to C. Let's calculate the C. For the C, the water supply line from the meter to house and up to second floor sink is 1-inch copper pipe with screw fittings. If the pipe from the meter to second floor is a total of 75 feet long and includes floaties, swing tank, valves, 7 regular 90-degree elbows. Now, which one you are going to use? Since it says screwed fittings, so you are going to use this table, guys, this time. You are supposed to use this table to be able to answer the questions. Okay. So I'm going to go to here and I'll answer them. If I take a screenshot here. So we are gonna calculate the length again. So we are supposed to calculate the length of the copper pipe. And if I calculate them, we have what we have here. So we have 7 90-degree 5.2 feet 1-inch copper pipe. So we are gonna, since we have 7 of them, 7 90-degree 7 90-degree 5.2 so times 5.2 feet each. So when I multiply them, 75 feet. So that's the which one? That's the this 7 90-degree elbows. That's 75 feet, and then what do I have? For line flow, I have 4 line flow, 4 times line flow times each one is 3.2 feet. When you multiply, the answer is going to be 12.8. And I have one swing check valve. It's hard to pronounce for me. I don't know am I pronouncing correctly, but one swing check valve. Each one is 11 feet. 1 times 11, that's going to be 11. So 75, 12.8, 11. And we have, oh, wait a minute. So we have 790 degree, 5.2 for each. When we multiply them, we are not getting 75. So it's going to be here. It's supposed to be 36.4. But we have the pipe. Length, a total length. The second floor is a total of 75 feet long. So we have the pipe length 75. So I'm going to just type it here. Pipe length is 75 feet. So when you add all these numbers, you are going to get 135.2 feet. So that's the length. And then we are going to, of course, use the formula, head loss formula, HF equals 10.44 times L times Q to power of 1.85 divided by C times 1.85 times D to 4.68. 868655. So here 10.44 is the constant. L we just calculated, which is 135.2. This is going to be go to L. Q is 10 in this case because we are using the different pipe. You can check it from the PDF document that's shared with you guys. This is going to be 10. And C is 130. And D is diameter. In this case, it is given to us. It says 1. So if you plug them in all these formulas, the head loss is going to be approximately 13 feet. Okay, so the head loss means the loss due to the friction. And we have already, what is total head loss? We have already lost 11 feet for the cast iron, right? So total head loss, and we calculate it, we have 11 feet from the 8-inch iron, and we have 13 feet for the copper, 1-inch copper. So when you add them, total head loss is going to be 11 plus 13 is going to be 24 feet. That is the head loss. How can we calculate the dynamic head? Remember, dynamic head equals static head minus head loss, which is 163. That's our new static head, because we are on the second floor, minus 24, and the answer is going to be 139 feet. So, and how can we calculate the actual pressure? Actual pressure, we just need to convert this value to PSI. And how can I convert them to PSI? Actual pressure, 139 feet times 1 PSI over 2.31 feet, 2.31 feet. The answer is going to be 60 PSI. As you can see, guys, what did I say? When you go to second floor, third floor, fourth floor, whatever, it's always pressure is going to be decrease. Okay, that's how you are supposed to answer question 2. Have a wonderful day.